Thank you for doing that for me. All right, for your warm-up, hopefully you did that during the announcements. What'd you guys get for your base for this exponential? 2, and then exponent, and then argument. What? 3? Where did 3 come from? Yes, 2 to the third power is the correct answer, but what is the argument part? 8, yeah. Okay, so when you convert it, that's called the argument. All right, what about for the log? What's the base? What's the base of the log? 2. Okay, and then the exponent? 16. And then the argument is x. Okay, remember we did that little heart thing. 2 to the 16 is equal to that x power, to that x argument. Okay? Questions on that part? We're going to use that to help us through these new rules. Chapter 13, we're just going to be talking about logs. So last chapter, we really focused on exponential. We did a little bit of logs, and now we're going to reverse it. We're going to do a lot with logs because you need to know some things about logs, especially for that SAT. So just like we have exponent rules, we have log rules. Okay, if you are not familiar with all the exponent rules, you really need to start getting familiar with them because they are very important. Okay, you need to be able to just do those things pretty quickly, like you can add, subtract, multiply, and divide. So exponent rules, when we multiply powers of the same base, we add them. We know that. Let's do an example. If I have x squared times x to the 5th, we're multiplying the powers, we're multiplying the same base. What's our answer? X to the 7th because we add them. Okay? Now, with a log, again, they're inverses of each other. So it's going to be kind of the reverse here. So when we're adding logs with the same base, we're going to be multiplying. And this time we're going to be multiplying the arguments though. They're not, well, in this situation, yes. No, the x is the base here. The argument is what is equal to in exponential, but I'll show you an example. So if I had log, we're going to use kind of like the same exact form here. If I have log base 2 of x squared, let's say, plus log 2 base 2 of x to the 5th, we're going to multiply them together. Just kind of, again, using what we know about exponential to now formulate a rule for logs. What are we going to do with those now? Based off our rule, yeah, we're going to multiply them. So now it becomes 1 log, which is actually really nice. So this is called condensing. We're condensing the logs, which we'll get more into soon. We have log base 2 times x squared. Log base 2 with an argument of x squared and x to the 5th. But we know what that is. What we multiply them together, what we get again. We're going to multiply exponents. We multiply exponential things, we add the exponents. So we're going to have x to the 7th. So you can see that we have the same answer, same argument here. Okay. Kind of cool how that works out when you're working with inverses. Hold on, give me a second. I want to plug in. So again, with logs, when you have the same base, you can multiply them together. That's called condensing. Again, we'll get more into the technical terms later on. All right, now let's do the reverse. When we are dividing with the same base, when we're talking about exponents, we subtract them. So for example, I'm going to use all the same ones just so that you guys can see all the different versions. Okay, we're using the x to the 5th and the x to the squared. Again, what do we get when we divide them? X to the 3rd power, good. Okay? Because we subtract exponents in that situation. I have 5x on top, I have 2 on bottom, I cross them out, and I still have 3. They're on the top. So now let's do the same thing when we're talking about a log rule. So this time when we're subtracting logs with the same base, we're going to divide the argument. Argument. Please always tell me if I spell things wrong because I can't spell. Okay, so same situation. I have log base 2 of x to the 5th minus log base 2 of x squared. So I'm just giving you an example here. So now I can condense it to one log, which is very beneficial when you're trying to solve for logs. We're trying to find an answer. But when I condense them, I'm going to end up dividing them. So I have log base 2 of x to the 5th divided by x squared. And we know what that is. What was it again? What's going to be my argument here? X to the 3rd. So I'm just using that to kind of get you guys to see that they go together. And now we're talking about logs. And you can go reverse. If I started here, you can expand them to get to that answer too. It depends on what your problem's asking you. You might need to go back and forth. Right? Again, this is just the rules we're just exploring right now. Now, when we're multiplying an exponent by another constant, it's the same as raising it to the power of that constant. Okay, so again, we're going to use that same kind of thing. If I have x to the 5th power, and I'm going to multiply it by a constant, still using that x to the 5th power and that 2, kind of relating them all together, what do I get? X to the 10th, because you're going to multiply them together. Same kind of thing for logs. When we multiply a log by a constant, and the constant is an exponent, it may be applied to the power. So what does that mean? For example, if I put that 2 out in front, and I have log base 2 of x to the 5th, again, using the same kind of numbers here to kind of correlate them together, all you're going to do is bring it up and multiply them together. So what do I mean by that? All I'm going to do is bring it up and multiply it so I get x to the 10th. They're kind of the same exact rules, but now we're working with logs. Okay? There's just like an intro of what's coming, and then let's do some practice together. Look when you're ready. So you really don't have to memorize anything new because it's the same as exponential. Okay? All right, so properties of logs. For any positive m, n, and b, where b and b cannot be 1. Here, so let's talk about these. We have these properties. We kind of just what we just did together, this is a summary of it. That's all that is. So, error avoidance. Don't make these mistakes. Okay, sorry. When I have log base b of n divided by n, it's not the same thing as the log of n divided by the log of n. That's actually a little bit different. We're going to get to the change of base here shortly. I'm not sure what day that's going to be. But don't make that mistake. It's just going to be m divided by n. Just the arguments are divided together. You will get a completely different answer if you take the log of one and divide by the log of the other. Okay? And then same thing for multiplication. Again, if you put in your calculator log of something times log of something, you're going to get a completely different answer than if you had log of the arguments just being multiplied together. Okay, so just a little bit of a forewarning there. Example 1, use the properties of logs to write an expression as a single logarithm. Assume all variables are positive, so that means we don't need absolute value signs here. So when I subtract, what is the multiplication? Sorry, I just gave you the answer. It's actually not the answer, I totally messed that up. But when I subtract here, what are we going to do with the arguments? Divide, yeah, I heard it. Okay, it's the same thing as exponents. When I am subtracting, it really means that we're going to be dividing them. So let's write it as one single log, log base 4. And all I'm going to do is I'm going to take the arguments in order and divide them. So I have 64 divided by 16. We condense, it's called condensing the log. Well, what is 64 divided by 16? Very good. So I have log base 4 is my final answer. And now you can actually answer it. If I was asking you to simplify, which you don't have to, does not ask you to find the answer to the problem, but we could, 4 to 1 power gets me 4. 1. And this is why it might be useful, because then if you did have a calculator, you'd now be able to do that without one. Right? So let's do it again. Here for B. I have a number all the way out in front. Do you remember what's going to happen with that? Is my argument. Yeah, I'm going to bring it up, and it's going to become that exponent. So now I have log base 5 of x to the 6. That's where we're at right now. And I'm just going to rewrite the other parts out just so that we have it. So plus log base 5 of y. So the only thing that changed here is in black. Now, when you see this addition sign in between, what does that mean we're going to do with the arguments? Yes, multiply them. Very good. Okay, so I have log base 5, and now I'm going to multiply them. X to the 6th times y. That we can't do anything with that. This is kind of making your brain do the reverse of what we did for exponents, because again, when we multiply them, we're going to add them together, but now we're doing the reverse. When we're adding, we're going to multiply. That's why they're inverses of each other. Okay, you have questions right now. No, this is completely new to you. You've never learned this, so bear with me. All right, we got lots of things going on here. It's super exciting, but let's see how we do. Okay, so you're going to still apply everything that we know about orders of operations here. We don't have anything multiplying. We do kind of a little bit. We have this multiplying here. So I see multiplication. What am I going to do with this number all the way out in front? I'm going to do with this number all the way out in front. It's going to become the what of the argument? Yeah, the exponent of the argument. So all I'm going to do is rewrite that. Log base 7, and in black here is what's changing, y cubed. All I'm doing, that rule is telling me that I'm allowed to do that. I can now bring it to the exponent. And I'm just going to write everything else out that hasn't changed, just so that I can do everything correctly and stay organized. Writing backwards. Ooh, well, let's do something right away here. Do you see something else that happened? What can I do with that 2 out in front, just like we did before? Yeah, make that the exponent. Let's bring that up here too. I'm going to use a different color so you can see that I changed that. And I'm going to still write out everything else. The plus was here. Look at me writing backwards. So let me just stop there. Do you have questions on any of this so far? I know it's completely new to you. You're just working with it a little bit better at it. Whatever you see a number out in front of a log, you can now bring it to the exponent of the argument. That's all we did for both of those 2 in black. Now we'll just go left to right. Okay, when you see addition here in the middle, what does that mean about the arguments? What are we going to do with them? We're going to multiply. Very good. Whenever you see subtraction, these 2 are both subtraction. You're going to divide. So my trick is that whenever you see any subtraction, I'm going to prepare it by drawing my division sign. Whatever is multiplying stays on top. Whatever is dividing goes on the bottom. Okay, so I'm going to put log base 7, where we are right now, because it's all one log now. We're condensing it to be one log. The goal is when you do these problems, at least in these situations, is to condense so you only have one log. Make it simple. So here we go, everything in yellow, that yellow part, I have 3 times x squared. So that was the yellow part. I took the 3, the argument of 3, and the argument of x squared, and I put it on top. Now that I'm subtracting both of the arguments go to the bottom. Yeah, I know this is completely new to you. You just have to bear with me. You will get better at it. So I have this 5 going on the bottom and the y cubed. And that's your final answer, because I can't do anything with that. So when you're condensing logs, take it piece by piece. Take your time. Rules of exponents are now going to be reversed to rules of logs. Whenever you see addition, when you're doing a big problem like this, the arguments go on top. When you see subtraction, the arguments go on bottom. Okay? And sometimes it's very useful in this situation, maybe not so much because we can't really get an answer here, but at least we're working with those properties. Okay, do you have questions right now? I know it's a lot going on right now. Okay. Let me start you off on this one, okay? So the negative here, what is imaginary in front of it? What do we have technically in front of this? A 1. So let's just first, just like you would do any other problem, let's distribute the negative in first because orders of operations still apply here. I see parentheses, so I'm going to distribute it in. So I'm going to distribute to both. Oops, sorry guys. Here. So I'm going to go ahead and distribute. I have negative log, so in red is what's changing. Distributed in, the plus becomes a minus. That's all that's happening. Did I lose anyone on that step of why I did that? In black is going to be the same. But now that I look at this, I see a number out in front of a log. What can I do with it? Yeah, I can bump it up to the exponent of the argument. Now you guys keep hearing me say argument. That's why we feel like it's very important that you understand what the argument is. The argument is always the piece that comes after the log. Okay, so when I say argument, make sure you know what I'm talking about. Otherwise, you're going to get lost in my notes here. So again, this is going to bump up the exponent now. So I have, so in red, because it's changing here, log x cubed. The only one that did not change in this situation is the black one. If you have questions on any piece of that, I'd be more than happy to go over it. All right, let's do our thing. Now, again, the goal is to get only one log and one log only. So I'm just going to go ahead and prepare that. I have one log. There it is. Do I see subtraction? Am I going to divide in my argument at all? Yes. So I'm just going to prepare that. Let's get that ready to go. When I see addition, what do I do with my arguments? I multiply them. Very good. Now, obviously, you can write x cubed 4, but because I'm a math person, I just like to write the 4 first because that's just me being a math person. If you would have wrote x cubed times 4, fine. I just like it to look like this. Still means the same thing. But now that I have subtraction, where is it going to go, on the top or bottom? The bottom. So all of the argument pieces are going to go on the bottom. Okay, so I have the x is going to go on the bottom and the 6. Oop. Yep, 6x. See, I just saw that. I was like, ugh, that's gross. Okay, we can simplify this just a little bit. A couple reasons. So I have log, still going to be here. What happens with the 4 and the 6? It reduces to, very good, 2 over 3. So in red, this is what's changing, 2 over 3. X cubed, now we're going back to rules of exponents. So see how it's all coming together now. What's x cubed divided by x? X squared is on the top or bottom of my fraction? Top, very good. Guys are being rock stars right now. We're all new. If you feel confused, it's okay. You will get better. Didn't know how to multiply right away. Didn't know how to do logs right away. That's going to instantly come to you guys. Okay. All right, let's see here. I want you to take a second and see if you with your group can answer example 2. Match the expression with a log that has the same value. If you do each one, 1, 2, 3, and 4, you actually do those problems, you'd be able to match them with A, B, C, or D. So go ahead and try that. Now would be a good time to ask questions if you need them. We're going to do 1 through 4 and see, I know, like do 1 through 4 and see if we can match them. We're dealing with them when they see subtraction. We divide exponents. You subtract these. Is that right? You guys are doing a fantastic job. Okay, let me go over this really quick. If I were to do each one of them really quick, when I see subtraction, I know I'm dividing. And you kind of can just remember that rule in general for both logs and exponents. Just know subtraction and division always go together. Subtraction kind of looks like division. Think about subtraction. It looks like a fraction sign. Okay, it looks like division, so they go together. Adding and multiplying go together because, again, look at they kind of look like each other too. So kind of a good rule of thumb here. And 6 divided by 2 is 3. So number 1 went with B. Here the 2 comes up. Oops. Hold on. I just lost it there. Here we go. The 2 comes up, and I get, what is happening? I get log 6 squared, which is 36, and that's why number 2 is D. And then same thing here. I have log 2 to the 6th power, okay, which is going to be what letter? A, okay? Seeing if you're paying attention. Okay, when I add these together, which really means I'm multiplying, so I have log, that's why this one. Okay, flip when you're ready. Okay, so the copy machine has been really bad lately. They're fixing it right now, so we apologize if your staples are falling, like mine just fell apart when I flipped it. We do have staplers if you do need them. Okay, so use the properties of log to rewrite the expression in expanded form. I told you what we just did was called condensing. Condensing to make only one log. Now we're going to go from one log and expand it. Because sometimes that can be more beneficial. And it sometimes can be a little tedious, but let's give it a go. So, what operation do you see right here on the top? Multiplication. Okay, so this is multiplying. What operation goes with multiplication? Addition. So let's go ahead and do that. Log 7, you're taking each piece and breaking it up. So each piece, the 3 and the t, we're breaking it up. So 3 plus log base 7 of t. We took care of the top. What does it mean when we divide now in green? What operation goes with division in terms of logs? Subtracting. So now I'm going to subtract log 7 of u. Again, it depends on the type of problem that we're doing. This might be more beneficial in the future. Okay, when we're trying to actually find the answer to a log, if multiplication or division is too tough to do. Or we can break it up into logs that we know of. Okay, in this situation, not so much, we're just practicing. Do you have questions on that piece? So it's the opposite of what we just did. Okay, this is called expanding. Now a trick for you guys in blue here, I have 1, 2, 3 pieces. So I should have 3 logs. Does that make sense? I have 3 pieces, 3 logs. Okay, let's do it again. I have how many pieces here? So how many logs do I need? Okay, perfect. What is going to go in between? What operation? Addition. You guys are doing fantastic. So I have log 4 plus log p cubed. Now, this is not completely expanded in terms of math, because now we see something else that we learned. Yeah, so instead of bringing it up, we're going to bring it forward. So let's do that one piece. So log 4, and now all I'm going to do is I'm going to bring this 3, I'm going to bring it down. So 3 log, we're done. Okay, so expanding is a little strange and like weird, but you definitely can go back and forth. All right, so here we go. I have 1, 2, and 3 pieces. So how many logs do I need? 3. Okay, so what operation is right here? Multiplication. So what operation is going to be in between them? Addition. Awesome. So 16, and that's why I'm going to put the addition in between. So I have log 4 square root x. That's a weird square root. Now I'm going to throw in this y to the 5th. What operation is going to be in between? Subtraction, because I'm dividing there. So the subtraction is going to go, and I get log base 4 of y to the 5th. Now this isn't 100%. 100% expanded. Let me ask you this question and see if you learned anything on extractor and factor before. What does a square root technically mean in terms of an exponent? Yeah, very good. 1/2. You guys might have not on a test that you took yesterday. There was a question like 36 to what power gets you 6? It was 1/2 because square root of 36 is 6. All good. Now you know. There was something like that. I don't think that was the exact question. It might have been. I don't remember. No, okay. I don't think it was the exact question, but at least knowing that 1/2 means square root is very important in terms of exponents. 1/3 really means the cube root. You need to start being familiar with those basic terms. So this one we really don't have to do anything to, so I'm going to leave it in black and keep it the same. I'm going to bring that exponent, which really is 1/2, out in front, and then everything else is going to stay the same. Because really x to the square root of x is really x to the 1/2 power. Okay, the minus is going to stay the same. What'd you say? Oh no. Okay, now I'm going to bring this 5 and I'm going to bring him all the way out to the front too. Because we're going to be expanding as far as we can. Because again, in certain situations, it's very beneficial. This one not so much for just practicing, working with our rules here. Try D. I'll give you one little hint. How many pieces do we have in this situation? We have 4, so how many logs do I need? 4. Okay, so you should have 4 logs because of every color I just put up there. 4 logs. Give it a go and see how you do. Challenging your brain right now. We're here for you. And if you can at least get the first step down, you've made progress. Maybe you can't get all the way to the end right now, hopefully you can. But that first step is a big step. And you write them into 4 different logs. And obviously, if you, just like we know exponent rules, if you start to get so familiar with it where you skip steps, if you know that 2's coming out in front of the y, do it right away. You don't have to do every step. What you say? Like in my brain, I'm like, okay, that 3, no matter what's coming out. That 2's coming out in front. I would have just went right to that part.
You still wrong though.
So where's Z? No, where's Z? The bottom means. Yeah. Get in there. Give him a second. Give him a second. Let him at least process the information. When you're done and when you're done only, you can take a look up. I'll start putting it up here. Hey, so you can see how my brain just worked. I didn't even have to do this step right here because I knew the exponents would be coming out in front. Again, if you need to step in between, please do the step in between. some of you I feel like are just so quick. You're really smart in this class. You guys are a pretty smart class. You really are. Last semester I think we had half of you had A's, which is like unheard of. Okay, so you guys are great. So if you're that person that can just go ahead and put that in front, great. If you can't, it's okay too. You use the step in front. You have questions on how I got any piece of that. Okay, both of these are on the bottom, and that's why they both have subtraction signs. Okay. A lot of people, one of the most common errors, and I did see it walking around, people put plus here because it's multiplying to the bottom, but it's on the bottom. Okay? All right. Determine the property, quotient, product, power used in each step. So, what are we going to do here for this first property? We're going to divide, which is called the quotient rule. You look like a quotient. Oh, we didn't do the quotient rule here. We did it here. Sorry. Because what did we do in this one? The power rule. Thank you. All right, that's it. You're fantastic today. All right. You got 12 minutes, 13 minutes. Oh my God, there's so much red. Oh my God. Wait till you go to all 9 you have like 15. My voice has been very cocky. If you have not finished your test or started your test, you need to make an appointment with us and when you're taking it. You have 1 week. We're not doing test a week anymore. It gets too complicated.